Symmetry, reflection and rotation. Symmetry. The concept of symmetry is already discussed in class 6. Basically, a geometrical figure is said to be symmetric about a line in it if, on folding the figure about this line, the two parts of the figure exactly coincide. In this video, we can discuss about symmetry, reflection and rotation in details. So what is symmetry? Symmetry comes from a Greek word meaning to measure together and is widely used in the study of geometry. Mathematically, symmetry means that one shape becomes exactly like another when you move it in some way, either turn or flip or slide. For two objects to be symmetrical, if they must be the same size and same shape, with one object having a different orientation from the first. There can also be symmetry in one object, such as face. If you draw a line of symmetry down the center of your face, you can see that the left side is a mirror image of the right side. Not all objects have symmetry. If an object is not symmetrical, it is called asymmetric. Number 2, reflection symmetry, sometimes called line symmetry or mirror symmetry, and reflection symmetry also. It is when an object is reflected across a line like looking in a mirror. The face mentioned before is an example of reflection symmetry. Here are some more examples of reflection. The line of symmetry does not have to be vertical. It can go in any direction. Also, certain objects like a square or a circle can have many lines of symmetry. সিমেট্রির মানেই হচ্ছে যদি আমি পার্টিকুলার কোনো লাইনে সেটাকে মুড়ে ফেলি কিংবা ফ্লিপ করি কিংবা স্লাইড করি তাহলে দুপাশে সেম একদম আইডেন্টিক্যাল ফিগার থাকবে। Rotational symmetry. If a point of figure is fixed and the figure can be rotated about that point, then the point is called the center of rotation. A figure is said to be rotationally symmetric if after certain degree of rotation it looks the same as it was in the starting or original position. এখানে দুটো পয়েন্ট আমরা খেয়াল রাখবো। পয়েন্ট 1, if a polygon has n sides, the maximum number of lines of symmetry of the polygon will be n. মানে যদি একটা ট্রায়াঙ্গেলের আমি লাইন অফ সিমেট্রি বলতে চাই তাহলে সাইড অফ ট্রায়াঙ্গেল 3, তাই লাইন অফ সিমেট্রি হবে 3। অ্যাজ ইউজুয়াল পেন্টাগনের যেহেতু সাইড 5, সো লাইন অফ সিমেট্রিও 5। Point 2, any regular polygon has as many lines of symmetry as the order of its rotational symmetry. Example, পেন্টাগনের 5টা লাইন অফ সিমেট্রি আছে, তার কারণ এর সাইডও 5 and rotational symmetry order হবে কি 5। তার মানে depending on the side, line of symmetry is same and rotational symmetry if possible is also same.
To understand what symmetry is, let's draw an isosceles triangle. It's a triangle in which two of its sides are equal. Now let me give you an easy task. You need to think if we can divide this triangle into two parts such that both the parts match exactly when they're folded along a line. How would you divide the triangle if this condition has to be satisfied? Fold it along a line such that both parts formed match exactly. Pause the video and give it a shot. It's easy and I'm sure most of you would have got it right. If we draw a line like this, the condition will be satisfied. Yes, it's a vertical line which divides the triangle into two parts, which match exactly when folded along the line. If the part on the right is taken over to the left, we see that they overlap exactly. And that is why this shape is said to be symmetrical. The two parts match exactly when folded along a line. Now let me give you another figure. I draw the isosceles triangle this way and ask you the same question. How would you divide the triangle into two parts such that both the parts match exactly when they are folded along a line? Yes, we can draw a horizontal line like this. We get two parts which match exactly. When one is folded or flipped, it overlaps exactly over the other. Both these lines we see here are called the lines of symmetry or the axes of symmetry. This triangle has a vertical axis of symmetry as this line is vertical, and this one has a horizontal axis of symmetry as this line is horizontal. Now I want you to think about the next question I'm going to ask you. Can a shape have more than one axis of symmetry? If you look at just these two triangles, you would probably say no, because there is no other line which can divide these triangles into two parts that match exactly. But the correct answer is that a shape can have more than one axis of symmetry. Look at this rectangle. These two parallel sides are equal, these two parallel sides are equal, and all four angles measure 90 degrees. It will have a horizontal axis of symmetry like this. When one part is flipped over, it will overlap exactly with the other. And it will also have a vertical symmetry like this. Flip this part and we see the perfect overlap. So a rectangle has a horizontal as well as a vertical line of symmetry. But wait, some of us may be wondering if the diagonals are also the axis of symmetry. Let's say we have a diagonal like this. You can see that folding it along the diagonal does not give us matching parts. You can try this with a page from your notebook. Try and fold it along the diagonal and you will see that the parts do not overlap exactly. Okay, here's another question for you. Can a figure have more than two axes of symmetry? If yes, then which figure? Again, the answer is yes. Take the example of a square. All its sides are equal and all four angles are right angles. It has a horizontal as well as a vertical axis of symmetry just like the rectangle. But for a square, the two diagonals will also be the axis of symmetry. If we fold it along this diagonal, the parts match. And even if we fold it along this diagonal, these two parts overlap exactly. So a square has four axes of symmetry: horizontal, vertical, and the two diagonals. More than four? What if we have a figure like a regular hexagon? A regular hexagon is a closed figure with 6 equal sides and 6 equal angles. How many axes of symmetry does a regular hexagon have? Pause the video and try to arrive at the correct answer. Okay, let's see. The horizontal and the vertical ones are obvious. These two diagonals would also be the axis of symmetry. Do you think there are any more? Yes, the line joining the midpoints of these two sides. And the line joining the midpoints of these two sides will also be the axis of symmetry. Folding the figure along any of the lines will give us matching parts, 6 in all. And a circle, on the other hand, has infinite axes of symmetry. No matter how we draw the line passing through the center, the two parts formed will always fold perfectly along that line. Did you know that nature loves symmetry? The best example of symmetry in nature would be that of a human face. It has a vertical axis of symmetry. What we saw in this video is reflectional symmetry. If one part is kept against a mirror, its reflection will give us the other part. Let's say we keep half the hexagon on this side of the mirror, its reflection will give us the other half. Hence it's called reflectional symmetry. Is there some other type of symmetry too? Yes, we will cover that in the next session. Let's draw an isosceles triangle. It's a triangle in which two of the sides are equal to each other. And we had seen in the previous video that it has a vertical axis of symmetry. If this part is flipped to the other side, we see that the two parts match exactly. And that's why we say that this shape is symmetrical. This is called reflection symmetry. Why is it called that? Let's see. If we take one part and keep it against a mirror, we will get the original shape. The reflection of one part completes the shape. But wait, what is the other kind of symmetry? Do we have another kind? To know the answer, here's another figure for you. This figure is made up of 6 squares to be precise. Now I want you to tell me if this shape has reflection symmetry or not. Can we draw a line through it such that the two parts formed match exactly with each other? If we try out different lines, we realize that no such line can be drawn. This shape has no reflection symmetry, but what this shape has is rotational symmetry. Yes, rotational symmetry. What does that mean? As the name suggests, let's try rotating the figure about its center point. And what does rotating about a center point mean? Take the example of this triangle. If we rotate it about its center point, it will rotate like this. If we rotate it about this point, it will rotate like this. And if we rotate it about one of its vertices, it will rotate like this. The shape will rotate differently depending on the point around which it is rotated. Now let's come back to our figure. We rotate the figure completely around the center point once and see how many times it looks exactly like the original one. Rotating it completely means rotating it by 360 degrees. Let's have a counter on the right which counts the number of times the rotated figure looks like the original. Let's start. Now the figure rests at 0 degrees. After rotating it by 90 degrees, we get this shape. It's not the same as the original. The counter is still at 0. Okay, so let's rotate the original shape by 180 degrees. And we see that it looks exactly like the original shape. It fits in perfectly. We see an increment of 1 on the counter. We continue rotating it till we finish one complete rotation. Rotating it by 270 degrees gives us the shape which is not the same as the original. And rotating it by 360 degrees gives us the original shape back. The counter changes to 2. What does this 2 tell us? It tells us that when this figure is rotated completely by 360 degrees, the rotated image looks exactly like the original image twice. Once at 180 degrees and another at 360 degrees. So we say that this shape has rotational symmetry of order 2. To recap, when do we say that a shape has rotational symmetry? Okay, this is long, so I want you to listen to it carefully. A shape has rotational symmetry if it looks exactly like the original shape a number of times when rotated about the center point by 360 degrees. Here, the number of times it looks like the original is 2. So we say that this shape has rotational symmetry of order 2. Is it easy to find the order of rotational symmetry? Let me give you a few shapes, and why don't you try finding their order of rotational symmetry? First, an oval looks like this. Next, a square, an equilateral triangle, and a circle. Each of them has rotational symmetry, but we need to find the order. We begin with the oval shape and start rotating it. Let's see how many times the rotated image looks like the original. Once and twice. We saw that it looks like the original shape 2 times after the complete rotation. Its order of rotational symmetry is 2. In a similar way, why don't you try finding the order of rotational symmetry for these 3 shapes? Let's start rotating the square now about its center point. 90 degrees, 180 degrees, 270 degrees, and 360 degrees. Clearly, the order of rotational symmetry for a square is 4. Now for the equilateral triangle. 120 degrees, at 240 degrees, and at 360 degrees. 3 times in one complete rotation. The order is 3. And now we come to the circle. What do you think will be the answer here? No matter how we rotate the circle, it will always match the original shape. It will have rotational symmetry of order infinity. So remember, a shape has rotational symmetry if it looks exactly like the original shape a number of times when rotated about the center point by 360 degrees.